Hey, welcome to lesson number 8. And today we are talking about angles in a circle. And we're looking at part 1 because there are several parts that I want to look at. So today I'm looking at only one particular part here, or one particular angle calculation. So I can determine an indicated angle using my knowledge and properties of a circle. So I want you to be able to tell me what angle is involved when we are dealing with internal angles in a circle. So the first thing I want to note is that in a circle, and we've talked about it, in a circle, there is 360 degrees. So what happens if I want to cut this circle into sectors or into pie pieces? What happens then? How do you develop this? How do you figure out the angles? That's what we're kind of looking at here in this particular segment. All right, so we're looking at internal angles when you divide a circle into segments. So one of the formulas you could end up with, number of segments. So how many pie segments will there be? You would take 360 degrees and you would divide it by theta. So if you take 360 and you divide it by the angle for that particular segment, okay, that angle, it would give you how many times you can divide 360 up, which then would tell you how many segments do you end up with. If you know how many segments you want and you need to find the degrees, then the angle of each segment, theta, would equal 360 divided by number of segments. Okay, so there are the two formulas that I want you to be aware of today. All right, the only thing I want to mark, just a reminder, theta is the central angle. Central angle for the segment. All right, there we go. So we're looking at cutting a pie into segments. So the first set of examples, how many sectors, okay, will result when each sector has an angle of 15 degrees? So what's happened here, and it always helps to sketch it out to help yourself. We have a circle, and each sector has an angle of 15 degrees. So how many sectors are we going to end up with? Well, if we know the angle, we want to know number of sectors. Number of sectors is equal to 360 divided by the angle, the central angle. So it's 360 divided by 15. Plug it into your calculator. Oops. There. 360 divided by 15. And we find out that we would have 24 sectors. So therefore, we will have 24 sectors. All right. So you're just taking that 360 degrees and you are figuring out how many pie pieces will result with a central angle of that given value. Second one, and I always say the sketch always helps. So each sector has an angle of 40 degrees. So now my piece of pie in here has a central angle of 40 degrees. So how many sectors will I have? So number of sectors is equal to 360 divided by theta. So 360 divided by 40. And we end up with 9. So therefore, there will be 9 sectors. All right. So that's going to tell me how many pieces of pie I end up with. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Now it doesn't all, not all 40 degrees, but all right. And then there is the opposite of that. What's the internal angle? And it should read central angle. What's the central angle of each sector if there are 15 pieces of pie. So this time, I don't know the angle, but I know there's 15 pieces of pie. And so on and so forth. So 15 pieces. So I want to know, what's this angle? What does the angle equal? Well, we know we have a formula for that. Theta equals 360 divided by number of our segments. So 360 divided by 15. And you go to the calculator. 360 divided by 15. And we'd find 24 degrees. So 24 degrees. So therefore, each angle is 24 degrees. Oops, last example here. So, piece of pie. Now there are 36 pieces, or 36 sectors. So if it was an actual piece of pie, you wouldn't be getting a whole lot if you cut the pie into 36 pieces. But to figure out how many pie pieces or sectors there would be, or what the angle, sorry, for each sector would be, 360 divided by 36, and you'd end up with 10. So therefore, each angle will be 10 degrees. And that's it. Fairly straightforward. There are those two formulas that you'll want to have handy. All right, and like I said before, this unit does have a lot of formulas.